Hello everyone, in this video we would now be discussing about probability. So you might have already heard of the term probably before, so meaning that if you would be making use of the word, you are neither sure that something will happen nor sure that something will not happen. So meaning that there is actually a degree of uncertainty in the word probability. So in a scientific standpoint, when we say probability, it actually deals with the likelihood. So likelihood that an event, or let's say an outcome, is to happen. So again, when we say probability, it is actually the science that deals with the likelihood of an event or outcome to happen or to occur. Okay, so for example, that we have a certain coin. So suppose that we have a coin, then you want to flip it. So if you would be flipping it, you are not actually, or you are not entirely sure that the result would be heads, or let's say that the result would be tails. Once again, there is an uncertainty. Or another example is that, for example, that we have dice. So let's say that you have dice, and when you are to roll a dice, you are not entirely sure that the result will be 1, 2, 3, 4, 5, or 6. So in this video, we will be solving for the basic probability and its mathematical value, how possible or how likely a certain event is to happen. Okay, so let me get this out of the way first. So I will be putting this to the side first for our lecture. Okay, so for our next lecture here, so I will be introducing to you the variables E and S first, whereas E is now the event or the set of events, and S is now what we would be calling our sample space. And meaning by sample space, this is basically the collection of all possible outcomes. Okay, so when we are to speak of probability in a mathematical standpoint, so in mathematical terms, we could say that probability or the probability of a certain event is equal to the ratio of the number of the events divided by the total number of possible outcomes. So this is now our basic formula for probability. Once again, the probability of a certain event to happen is equal to the number of that event, or of the collection of the events, divided by the collection of all possible outcomes. So suppose that we have, once again, dice. So let's say that we have this particular dice here. So for example, that you are solving for the probability that, let's say, once that you are rolling the dice, what is the possibility that you will be getting the number, let's say, 4? So the probability of you getting a result of 4 when rolling one die is equal to, so once again, for the event, so for the event, again, we are solving for the probability that 4 would occur. So for the total sample space here, the total sample space, if we would be listing all of them, 1, 2, 3, 4, 5, and 6. So if you would be counting all of this, we have 6 total outcomes. So in here, if we want to solve for the probability that 4 would occur, we would now be counting for all of the possibilities here. Once again, if we would be counting this is now equal to 1. So the number of the event is just 1. Even though that this is number 4, it only occurs just once. Okay, so what about for the sample space? So for the sample space, if you would be counting all of the possible outcomes, that is 1, 2, 3, 4, 5, and 6. So meaning that this is 6. Meaning that the probability of a certain dice to have a result of 4 is equal to 1 over 6, or one possibility out of 6 total outcomes. So suppose that we are now to calculate it looking at the calculator to your left. So that is basically 1 over 6. So meaning that this is 0.16667. So this is actually the rate of probability. And for probability, it is oftenly shown in percentage. So in order for us to convert this into percent, just multiply it by 100%. By 100%. So from that, just multiply it by 100. So 16.67%. Okay, so fun fact, when we say percent, so if I am to write it here, percent, this basically means per cent or per 100. So meaning that for a rate of 16.67%, this means that this is basically 16.67 per 100. So with that being said, our ratio of 1 over 6 means that there is actually a possibility of 16.67 events per 100 sample spaces. Okay, so with that, let us now proceed to our first sample problem here. So in this sample problem, two coins, so let's name them as coin 1 and coin 2, they are tossed simultaneously. So meaning that, of course, simultaneously in Tagalog, sabay po silang itotoss. So what is the probability that at least one of them would be tails? And another question here, what is the probability that coin 1 will result to a head? So again, our base formula here for a probability of a certain event, that is equal to the number of the events divided by the number of the total sample space. So I will name this as problem A, and let's say that this is now problem B. So for problem A, so what we would be doing here is that we would be solving for the number of events and the number of sample space. So let us list all of the sample space first. So for the sample space, since we have two coins tossed simultaneously, so one possible outcome is that the first coin is heads and the second coin would also be heads. Okay, so that is outcome number 1. So for outcome number 2, let's say that the first coin is heads and coin number 2 is tails. Then listing everything. So aside from these possibilities, we also have a possibility that the first coin will be tails and the second coin will be heads. And lastly, there is also a probability that the first coin would be tails and the second coin would also be tails. Okay, so from that itself, the number of total outcomes in the sample space would be 1, 2, 3, and 4. So we have 4. Okay, so for letter A, I will now be naming the event as event 1, meaning that event 1 is at least 1 would be tails as per indicated in the problem. Okay, so let us now list all of the possible outcomes that at least 1 would be tails. So it is now the following. So this is at least 1 tail, at least 1 tail, and 2 tails still falls under that category. So meaning, guys, this is now equal to, so HT. So this is now possibility number 1, possibility number 2, and then possibility number 3. Okay, so from that, the total number of events in event number 1, that is now equal to 3. So with that being said, the probability of event 1 is once again equal to the number of possibilities for event 1 and divided by the number of the total sample space. So from that, that is now equal to 3 over 4. So 3 over 4. So this is now equal to 0.75. So if you do not believe me, just look at the calculator to your right. Left, I should say. So 3 over 4. So 3 over 4, that is 0.75. And if you would now be multiplying it by 100%, this is now equal to 75%. So this is now the probability that when you are to toss two coins, the result will now give you at least 1 tail. Okay, so another thing, what is the probability that coin 1 will result to a head? So same old, same old. So suppose that this now be For event number 2, let us say that event number 2 is now the event that what was that again? So, coin 1 is heads. Okay. So from that, let us now count from the total sample space which of this would now be having coin 1 would be heads. Okay, so from that, we will now list all of the events wherein the first one will be heads. So if we would now be counting them, this is just 1 and 2. So this is not included, of course, because coin 1 is tails. Anyway, so solving for them here. So for E2, so E2 is now equal to, what are those events? So that is HT and then HH. So we only have 2. So meaning that the number of events in event 2 is of course 2. So from that, the probability that event 2 will happen is now equal to 2 over 4, giving us an answer of 0.5. And if you would be multiplying it by 100%, this is now equal to 50%. So there.